Welcome, everyone. Welcome, a warm welcome, and once again, a warm welcome to everyone. Uh, oh, so today is the last year. Oh, sorry, last day of the year. Okay, and we are already all ready to welcome the new year. And we thought that it will be a great idea to end the year with the last episode of the quality talks for this year of 2020. And thanks for showing so much of love to us. And for the special session, the last day of the year, we thought we'll have our own master black belt. He's a very nice, intelligent, hardworking, and one of the best master black belts Anexas ever had. And of course, he has been around for last 6 years with us. But let me introduce you to him. Many of you already know him because I'm sure many of you have undergone training by him. He has most of the time he is there with me in the in all the Lean Six Sigma training programs. Of course, we have got Vignesh and Anil Kumar also, who also support us in the whole training program. So it's a collective effort. And the guy you see here, the photo, he has been responsible for implementing a lot of projects. That's the beauty of it. That's the best part of Gopi. He has been for the last 6 years. He has been involved in so many projects in railways and many companies in Saudi Arabia, in India, GCC in general, Jeddah, Dammam, and almost all the you know domains. It can be manufacturing, services, petrochemicals, chemicals. Uh, say he's a certified Lean Six Sigma Master Black Belt. He has to be, of course. He is also ISO 9001 2015 certified quality auditor and IRCA certified lead auditor. And he has more than 10 plus years of work experience, in which 5 plus years has been into Lean Six Sigma training and consulting, and 5 years of QMS implementation. In fact, it has been 6 years now with Anexas doing Lean Six Sigma training and consulting. And he has completed more than 150 projects, and some of the projects he's going to present 3 projects. So I told him to present some projects, especially from manufacturing background, because a lot of people were asking about manufacturing background. So I told him to present that and requested him to do that. And we are so happy that he's here with a smiling face. And yeah, so here we go. Gopi, over to you. Please let us know which projects you are selecting and or which projects you are presenting. And welcome to the Quality Talks.
Thank you, sir. Thank you so much. Thanks for inviting me. First of all, very good evening to all of you. My name is Gopi Krishna. I would like to thank Nexus and all the team to invite me or to having me here in the Quality Talks today. So I have total 11 years of work experience, and in which from past 6 years I'm with Nexus doing the training programs in Lean Six Sigma, and also implementing the Six Sigma in many industries. So today I'm gonna show you some projects, showcase you some projects from manufacturing, especially, and then service organizations. So I'm gonna show you 3 projects which are from manufacturing and service also. So in the 11 years, first 5 years, I was into implementation of quality management system in oil and gas industries. I was there in oil and gas industries implementing the quality management system, especially the API, American Petroleum Institute standards. And then I moved to Anexas, and it's almost 6 years I'm with Anexas. And I was there in Saudi for last 4 years, and then recently moved to India and responsible for conducting the training programs in India. So now I'll be showing you some projects where in these 6 years, I've been to many organizations, manufacturing, service, hospitals, and banking, and other service organizations. and done a lot of projects by using Lean Six Sigma methodology. Also, I've completed process re-engineering and process improvements in the organizations by using BPM concepts. So let me show you some projects. I hope you can see my screen. So today, the first project I'm going to show you in manufacturing organization. So this project I have guided and completed in one of the manufacturing organization in Saudi Arabia. This is in fact the aluminum manufacturing organization. So the title of this project is to optimization of scrap AGV travel time. So here in the organization, they're producing aluminum, they're manufacturing the aluminum, and then they're having different mills, raw mills, hot mills, and cast houses. So the scrap AGV is automated guided vehicle, which is the operation of this AGV is to carry the scrap from one unit to the other unit, and then so when they are doing this process, the automated guided vehicle, it is stopping in between due to the failures. So we did this project, we took up this project to reduce the travel time, especially the whenever it stops and the scrap is accumulating and it is causing problems in the mills and workshops. So now we are going to show how we have identified the root causes by using Lean Six Sigma methodology, and how we have implemented the solutions, and we have got the benefits after implementing the solutions. So the process is a scrapping, and of course the master black belts are myself and Amitabh Saxena. We have guided these projects. So before moving forward, I would like to give you a brief introduction on the process. So in the aluminum rolling mill company, so there are so many mills like hot mill, cold mill, and finishing mill, which produces aluminum scrap. So during the process of making aluminum coils. So to remove the scrap from each area, the AGVs are assigned there, which works 24/7 and covers all the plant. So the AGV delivers the full scrap bin, which is the a tub. So it carries the scrap from one area to cast house with the details of the scrap which contains in it. So these are the mills. Rolling mill contains hot mill, cold mill, and finishing mill, and it carries to the cast house. So the scrap AGV, it is a forklift which is automatically working on in order to provide the empty scrap bin and picks up the full scrap bin to the raw mills and cold mills. So this is AGV stands for automated guided vehicle, and this is how the vehicles looks like. These are the scrap AGVs, the first two pictures. And this is a spool AGV, which are working in the mills. And this is a coil AGV, which is after completing the aluminum coil. So now our focus is on, reducing the time, which is from scrap AGVs. So basically these are taking more time, to carry the scrap from one area to another area. So this is how the plant looks like. And here, it covers the areas in the rolling mill. This is complete rolling mill, and it delivers the full scrap into the cast house. So cast house you can see on the left side, and these are the 13 stations where scrap is accumulated, and AGV took the scrap from these 13 stations to and delivers to the cast house. So now we are taking this project to reduce the travel time from this area to the cast house, and then it returns the empty scrap into the mills, rolling mills. So what is the problem? The problem is, sometimes AGV gets stops due to the failures in the AGV. And when it stops, the scrap is accumulated and we are having, production issues, and it negatively impacts the mill production. So this is this is how it stops in between. And we took up, we have implemented a DMAIC approach, DMAC approach, and in the define phase, what we did was we have defined the problem that we are facing in the organization. So we have explained here in the business case why are we taking up this project. The project is linked directly to the mission and vision of the organization and strategic objectives of the organization. And because of this, AGV, the optimizing of AGV travel time will improve the customer satisfaction, because we are having different mills in the organization. They are the customers, So it improves the customer satisfaction and also reduces the stoppage of our AGV. It also encourages AGV to have more choices and to transfer the scrap. So the AGV travel delay costs approximately 196,475 US dollars for financial loss over the past 3 months. So this is a problem statement. So since in 2018, the June 2018, so the AGV has been wasting time on the way to cast house after finishing the work. So based on the data, so we have also collected some data based on the data from 3 months, which is June to August. So the total travel delay was approximately 5.07%, which approximately 37,870 minutes, which is wasted by the AGV. So because of this problem, because of the delay in travel, we are losing the production, and the customers are getting affected, they are dissatisfied. So our goal was to reduce from 5% to 4% by 13th of December 2018. So we have given 6 months time period, 4 to 6 months time period to implement the to reduce the travel time from 5.09% to the 4%. And we had also initially we had measured the sigma level, and these are the sigma level and opportunities. And you can see the scope is, which is given here. The team focused on reducing the AGV travel time from a mill to cast house. So to improve the AGV performance, the team works on preventing mechanical issues and improving the AGV process. And the process starts from these are starting step of the process. AGV changes the full scrap bin to the empty scrap bin at the station, and finishes when AGV arrives to the door before the cast house. So this is a travel time. Once it lifts up the scrap bin from the rolling mill or the mills, and then it reaches to the cast house, this is called as a travel time. So approximately the estimated benefits are $13,860 per month. This is monthly, and this was a timeline which we had. Our target is to complete this project by phases: define, measure, analyze, improve, and control. So this was the project chapter, which was agreed upon with the team members and all the stakeholders of the process. This is a high-level timeline which we have assigned to complete the project. For the define phase, what is a timeline, measure phase, and improve, control, analyze. Then, so once we define the problem, we have started understanding the process from a high-level way. So if you remember in the DMAIC, each phase has certain tools to be used. So here in the define phase, we're gonna use project charter, we had seen already, and then CPHQ, which is a supplier input, process output, and customer, which helps you to understand the process. Then we have the next tool, which is collecting the voice of customer. So let us now look at this CPHQ. We have understood the process in a high-level way. So here the customer is different mills in the organization, and the output is the scrap details and the full scrap bin, and then the empty bin to the returning the empty bin to the customers. So here the process is high level. These are the high level process steps. Customer requests whenever there's a scrap is accumulated. Customer requests the bin, and then request for AGV, and then AGV receives an order and goes to the place, and then it finishes the work at the mill, and then AGV moves to the cast house. So these are the high level steps in this process. And the inputs which are required to do this is the scrap bin and the location of the scrap bin and what kind of scrap it is, and then the request. And we have the supplier who is providing the AGV, which is a AGV system. So this helps to understand the process in a high level way. So once we understand the process in a high level way, the next thing what we did was we have further we have further completed a swim lane process map to understand more about the process. And this is the swim lane process map. So you can see different departments or different different departments which are involved in this process from the beginning to the end. So customers and AGV system, what customer does, customer requests AGV, and what AGV systems does, it receives the request and give the order to AGV, and then AGV move to the station and finish the work, and then it goes to the cast house. And we have also in between AGV operator. Whenever the AGV stops in between, it sends the signal to the operator saying that there's so and so problem, and then the AGV operator fix the problem. Then once we understand the process, we have further collected, we have further collected the voice of customer, and this is a voice of customer. We use QFT to understand the voice of customer. So when we collect the data, we came to know that these are the problems that customers are facing from the AGV, which is AGV is not available, and the other one is AGV arrives lately, and then it stops in between during the work, and it shows some errors on the path, and it also gives some it is also causing some problems to the work. And the priorities are we had assigned some priorities. The first priority is the we have rated on higher side, which is 5 means which is very important to the customer, and then 4 is after that. So and then we have 3 and 2. So first we are focusing on reducing the solving the problems, which is AGV not available and late arrival of AGV, and then AGV stoppage during the work. And this is the cost of poor quality. Because of the unavailability of AGV, we are having some financial loss, and financial loss is approximately equal to $196,475. So this is calculated based on the failure cost, maintenance cost, operational cost. Then this was about a define phase. We have defined the problem, and we have understood we have collected the data from the customers and given the priorities, and also understood the process in a high level way. Then once we define the problem, now we will be moving on to the measure phase. So what we need to do in measure phase is we had collected the data in the measure phase from the process. So what data we had collected? The data is from the AGV system database, and last 3 months data we had collected, which is the time period from June to August 31st in 2018. And what data which was collected from the AGV, which is AGV transaction life cycle and AGV optimal transaction time, and then the charging time, and then the delay time. So these are the data factors which we have identified and collected the data. So you can see on the below, these are the metric names, and what is a metric type, and then what data it is, and then the definition, operational definition, and then who is going to collect the information, and where the data is available, and from where we have to collect the data, and then how many samples that we need to collect, and then what is a method of collecting the data, and what is a frequency of data collection. Okay, so this is a data collection plan. So we have designed a data collection plan, and we had collected the data, and this is actual data which was collected from the process. Then once we collect the data, we have looked at, we have started understanding the process, how the process is behaving, what are the, is the data is normal or not normal. And you can see this is a graphical summary which explains us, which tells us, what is the average travel time of the AGV, and then what is the standard deviation and other statistics which describing the data as well. Also, we are also looking at the normality of the data, whether the data is normally distributed or not normally distributed. So you can see based on the, we did the graphical summary, and we have understood, we got the p-value, and it is less than 0.005. So which means data is not normal. That's what we had mentioned here. So the test that we did is Anderson-Darling normality test. So since the p-value is less than 0.05, it indicates data is not normal. Then we have also started understanding the trends and patterns in the data. We perform the run chart. Run chart is useful to understand the non-random variation in the process. And so we did this, and we did not see any non-random variation here. The data is performing good. It is in control and good. Then once after collecting the data, we have started understanding the capability of the process. We measured the sigma level of the process. So we have understood CPHQ values. So here the sigma value of our process was 2.19 sigma. So the defects that we are producing whenever the AGV stops, this is our defect. So currently, out of 1 million opportunities, the defect rate is 24.66%, and the DPMO is 246,629. So we have set the upper and lower specifications. So lower is the 10 minutes, and upper is it should not take more than 40 minutes. So whenever it takes less than 10 and more than 40 is a defect for us. So we have total 224.66% is the defect rate in the current process, and the sigma level was 2.19. So this was the understanding the process performance. Then once we understood the process performance, what we did was we have started collecting the information. Why are we having 24% defects? What are the problems of these failures? So we conducted the brainstorming session with the people who are working with the process, and then we have collected the data also on the failures. So the failures are the most frequently occurring failures are the RFID failures on the AGV, and then obstacle detected and AGV lost its position. So we did the Pareto chart to understand the most frequently occurring cause, which is you can see here, out of these three, the RFID failures, which is occurring very frequently, approximately 71% of the time, the RFID failures is occurring. And then they followed by obstacle detected and then its lost position. So out of these causes, the most frequently occurring causes RFID failure. We are going to and obstacle failures. So we are going to work on these causes. And then we did a further cause and effect diagram. We performed the brainstorming with the process owners and the people who are working in the process, and we identified the possible causes or potential causes. So these are the potential causes because of which the AGV is taking or AGV is traveling, delayed travel. So we have also named as X1, X2, X3, and X4. We have categorized those causes as well. So the categories of those causes are RFID read failure, and then obstacle sensor failures, and then we have laser scanner issues, and then we have a delay response from the operator. So now what we are going to do is we are going to validate all these causes by using statistical tools, by using the hypothesis testing, and by using ANOVA, and by using Pareto charts and graphical summaries. So now we're going to validate these causes. So we also did the failure modes and effects analysis, FMEA. We have identified for each X factor, we have identified the potential causes, and this is our FMEA. And then we further collected the data on the X factors, and then we started analyzing those X factors. So here X1, the first X factor is the RFID failure. So we are having total, 10 AGVs, automated guided vehicles. So whatever the RFID sensor failures we are having, the X factor is the RFID failures, and in the X factor we have 10 different AGVs. So are these 10 AGVs are having the same RFID failure, or are they different? This is what we want to understand. So we have collected the data on all the 10 AGVs, and we performed ANOVA because there are more than 2 levels in the X factor. That's why we performed ANOVA. So here null hypothesis would be all of the AGVs are having the same RFID failure problem, and the alternative would be they are having a different failure rates. So when we did the ANOVA, we came to know that the p-value is 0.679, which is more than 0.05. We compare our p-value with the alpha, and we came to know that when the p-value is more than 0.05, we accept the null hypothesis. That means so all the AGVs are having the same RFID failures. So all scrap AGVs has no difference about the frequency of RFID failures. So that means this X, whatever the X we have here, it is not a cause. It is not causing the delay in our travel time. Then there is a X2, second X factor, which is obstacle sensor problem. We have collected the data on all the same, again 10 AGVs, and the null hypothesis, they are all equal. The sensor problem is equal to all the 10 AGVs, and alternatives they are different. So we performed ANOVA because we have 10 different AGVs, and the p-value was 0.046, so which is less than 0.05. So this is, since the p-value is less than 0.05, we should accept the alternate hypothesis. We should reject the null and accept the alternate. So that means whatever the AGVs that we are having, they are not same. The obstacle sensor problems are different for the AGVs. If you look at here, there is one AGV number 1 and AGV number 7. They are having a statistically significant difference in the obstacle sensor problems. So 1 and 7 are different than the other AGVs. So what are we gonna do? We're gonna focus on these AGVs. One AGV is having less obstacle sensor problems, and the other one is having more obstacle sensor problems. So we need to further analyze this data. Why these AGVs are different than the others? Since this is X2 is a cause now, because it is causing the delay in our travel. And then the other X factor, which is a laser scanner problem. So here the p-value, same 10 AGVs we are having. So are they having same laser scanner problems, and are they different? So null hypothesis is they are all equal, and alternatives they are different. So the p-value, which is 0.329, so which means we will have to accept the null hypothesis. We had accept the null, which means there is no different. They are same. Then the other X factor, which is delay in response from the operator. So we have two operators working on day shift and night shift. So is the response time between the operators, is it same between the shifts, or is it different? So we collected the data on the response time, and here we have the two shifts. One is a night shift and day shift. So we had performed a 2T test because we have two groups, the day and night shift. We came to know that the day shift is responding in less time as compared to the night shift. That means night shift is taking more time. So that's what we can see here in the bottom left diagram, day and night. Is that significant? Yes, it is, because the p-value is 0.001. So since p-value is low, we will have to accept the alternate. So there is a difference of delay in response time between the day shift and night shift by AGV operators. So this is a cause. So by doing the root cause analysis, we came to know that this X2, which is the say obstacle sensor problem, and the X4, which is AGV operators, in the shifts are causing the delay in travel of AGV. So what are we going to do? So we have identified from the potential causes, we have identified the root causes. So from the 4 causes, now we came to know that the X2 and X4 are causing the variation in the travel. So what are we going to do? Once you identify, we're going to identify the root causes. We're going to implement a solution to eliminate those causes. So this is by in the improve phase, we are going to generate the solutions and implement the solutions. So let us do that. So these are the identified problems and the solutions on the right side. So once we implement the solutions, we have further collected the data on the process, and we have compared the performance of AGV travel time before with after data. So earlier we were having the mean, which is 25 minutes, and after the mean is 20 minutes. But is it a significant improvement? That's why we performed a capability analysis before and after. And when we did the performance capability analysis, we came to know that there is a reduction of 27% in the out of specifications. So reduction in percentage out of specification is 27%. They have reduced from 24% to 18%. Earlier our defects were 24.6. Defect rate was 24.66%. Now it reduced from 24 to 18. Okay. Was the improvement significant? Yes. Look at the p-value. P-value is less than 0.05. Yes, it is a significant improvement. And also we have we have and then compared the performance of before and after by doing the hypothesis called 2T test. So we did the 2T test, and before it was the travel time is 25, and after the travel time is 20 minutes. But is it a significant? So we did a 2T test, and we came to know that the p-value is we framed the null and alternate. Null is there is no difference. I mean, before and after, before is equal to after time, and we believe that after implementing the solutions, the travel time has reduced. So it means after is less than before time. And then the p-value which was produced as less than 0.001, which means the improvement is significant. So after implementing the solution, the travel time has got reduced by 5 minutes. So once we saw the improvement, we put a control plan in place. This is a control plan. So we will have to continuously monitor the process. Otherwise, what would happen is if we do not monitor the process, it may fall back to the it might fall back to the previous earlier stage. That's why we made a control plan. So these are the people and these are the actions needs to be taken. So what is a process step and what control, what item to be checked, and how many times to be checked, and what is a frequency, and what is a target, and how to check, and then what is a response. So on the left side you can see the control section, and the right side you would see the response section. These are the controls and responses. And then we also did the control charts to compare the performance of before and after. So earlier, if you look at the left side diagram, there's so many outliers in the process because our process was not in control. And after implementing the solution, the process is, you can see the mean, which is less than 20 minutes, equal to 20 minutes. And also still there is a variation, but we try to reduce the variation. That is by doing the continuous improvement projects. So these are the control charts of this process. So this was about the project, which is AGV travel time. So by implementing the tools and techniques of DMAIC, the Six Sigma, we were able to reduce the travel time of this AGV. So thereby saving thousands of dollars per month. So this was the project. So let us also see the other projects as well. Now I'm going to show you a project which we had done in railways. By using same DMAC approach. This is also focusing on reducing the time, reduction of cycle time in repairing the coaches. So same, we used a DMAC methodology. So in the define phase, we have defined our problem. The problem is, now the tools, the first thing that we did was, we understood the process in a high level way. And here the process is, whenever there's a timeline to repair the coaches. So every 12 months, every 36 months, or every 48 months, the coach has to come back to go to the workshop, and it has to be overhauled completely, and then they put this coach in the line for travel purposes. So this is what corrosion repair of periodic overhauling of the non-AC ICF coaches. These are non-AC coaches. And customers are the different divisions in the organization, and the output is the uh, overhauled ICF coach. And these are the detailed process steps. Once they receive the coach in the incoming line, and then they stripping the components, and then they place the coach in there's a shop number 18. This project particularly did in shop number 18 of that organization, that branch. And then corrosion repair, they repair the corrosion, and then they do the finishing work, and then they lower the coach, and then they fit all the components, and they do the painting, and then they test it to the final inspection, and then they dispatch it to the departments or divisions. And what are the inputs required to do the process steps? So input is the coach and the manpower, required tools, machines, electricity, traverser, cranes, materials, engines, etc., measuring instruments, etc. These are the required inputs to do the process. Then we have the suppliers who are providing these inputs. So administration is providing also the inputs, and also the store. So these are the suppliers. So we have understood the process in a high level way. And then we have started framing the charter, project charter. We have explaining what is a problem that we are facing in the organization, and what is a goal that we would like to achieve. So the problem was the cycle time. As we said earlier, cycle time is currently to do overhauling of one coach, it was taking 39 days, right? So our target given by the management was only 32 days. So we are gonna reduce, our goal is to reduce this 39 days to 32 days by so and so by March 2020. This was completed in last March, just before COVID. So what are the benefits? Why are we doing this project? Or are there any benefits of doing this project? Yes, there are benefits. So the benefits are by reducing the overhauling time from 39 days to 32 days. We are going to benefit the savings of 114 lakhs can be achieved to improve the that improves the that also improves the reliability of ICF coaches which are dispatched. So these are the monetary benefits. And then team members are there who helped us in completing the project. And the scope is only from receiving the material to dispatch, final dispatch of the coach. This is what the scope, the starting point and end point of the process. And then the CTQ is a measurable term, which is the cycle time of ICF coaches. And these are the timelines: define, measure, analyze, improve, and control. So once we complete the charter, we collect the signatures from the stakeholders, and this is the agreed timelines and agreed problem statement and goal statement from the stakeholders. There is a Gantt chart which would help us to keep us on track to complete the project. So this was the CTQ. Then once we identify the problem, we started collecting the data on the Y output as well as the X factors. So we have identified the factors which are causing the delay in the POH overhauling, and these are the X factors and Y factors. So X1, X2, we have named them as X1, X2, X3, X4, X5, 6, 7, 8, 9, 10. So total, when we did the brainstorming with the process owners and the team members, we came to know that there are 10 X factors which are possibly impacting on the cycle time of the overhauling. And then we had collected the data on the output, which is the cycle time from around 90 or 95 samples data we had collected, and this is the data which was collected from the process. So you can see the total number of working days, what date it is received and what date we dispatched, and what is a coach number and what type it is, and then what are the actual number of days, and then working days, and then is it a defect or not. So if you see here, wherever you see the highlighted in yellow color, they are the defects because they are taking more time. The given time is 32 days. If you look at the highlighted ones, they are more than 32 days. So that's why we we highlighted them as a defects. Out of these many samples, once we collect the samples, we have started understanding what is the average cycle time. So the average was 39 days. So we were taking 39 days to do the overhauling of the coach with a standard deviation of 23 days, which is very high. And also we measured the sigma level of the process, and the DPMO, defects per million opportunities, are, if you look at here, 618,922 out of 1 million. So what if we do 1 million coaches? What are the chances of producing defects? The chance of producing defects are 618,000. So which is on a sigma scale, the sigma level of the process was 1.2. So we were able to meet only 1.2 sigma. So once we understood the sigma level of the process, we moved to analyze phase. We collect the data on those X factors. We did a brainstorming session and performed the cause and effect diagram. And we have identified many causes, and we have also categorized those causes under the 6 M's, like man, machine, measurement, material, mother nature, and machines. So these are the causes. And then we have further collected the data on the X factors. If you see here, this is the data on Y. Y is the cycle time, and these are the X factors data. So X1, what was the time? X2, X3, X4, X5, X6, 7, 8, 9, 10. So So all the X factors data which was collected from the process. Now we are going to validate these causes. Is the variation in the cycle time because of this X1 or because of X2 or is it because of X3? So these are the 10 possible causes. Let's go back. Yeah. So now Six Sigma analysis of initial data collect. These are the data which we had collected just now, and now we shall analyze all the data to understand the relationship. So let us do that. So we used scatter plots, box plots, and Pareto charts to identify the causes. So this is X1 with Y, and we came to know that this is having a strong relationship with your X1. So why it is a strong relation? Because if you look at here, when you are taking more time in the X1, the Y, which is a cycle time, is also increasing. If you want to reduce the cycle time, you need to focus on reducing the X1. So this graph is called as a scatter plot, which shows the relationship between two variables. And then we continue to use the scatter plots because our Y is a continuous data and X's are also continuous data. So these are the different X's we are verifying with our Y, and then identifying whether they are causing the variation or not causing the variation. So wherever you see here, this X6 is directly causing a relationship, and then X7 it is not a relation because the data is scattered. Even if you work on this X7, it's not going to reduce your cycle time. Similarly, X8 is also same, and then X9, and then we have the other X factor, which is 10. So we have used here the box plot because our the factor here is the attribute data, and the Y is a continuous data. That's why we use box plot. So by doing this analysis, we came to know that these are the three causes among those 10. These are the three causes which are affecting the cycle time. So out of 10 numbers data collected, following are the main root causes. These are the causes which are affecting our cycle time. So what are we going to do now? So we did, after identifying the causes, we implemented the solutions. We used some brainstorming tools. There's a technique called 635 technique. So we used this 635 technique, and we had completed the generating the solutions. And these are brainstorming activity. These people are involved in the project. They're doing the brainstorming to identify the solutions. So these are the solutions of each cause. So they've generated for each cause 4 or 5 solutions, and then later on we have also done the solution selection matrix. So out of these 5 solutions, which solution shall be implemented? So we did that exercise, and we had chosen the solution, and then this is what the solution implementation plan. So what action to be what action to be completed, and who is responsible to implement that action, and what is the target date. So after implementing the solutions, we further collect the data. We had collected the data, and this was the data, and we also looked at the performance of the process, and the defect rate was reduced, and the sigma level also has improved a little. So earlier it was 1.2, now we have moved to 1.2 to 1.3. There's a slight improvement. Then we have also to show it to the management that whatever the solutions which were implemented, we have started collecting the evidences whether people are following the solutions or not. We were we had collected the evidences, and these are the evidences. And then there's some more photographs, and these are the photographs of the solutions which were implemented. Then once we saw the improvement in the project, improvement in the process, we will have to monitor the process for the effectiveness. So we moved on to the control phase, and in the control phase we have created a control plan, what activity to be monitored, and who is a responsible person, and at what frequency they have to monitor the process, and what action to be taken when the process is not in control. Then we did the control charts, and these are control charts after implementing the solution. There is a special cause. If you see here, there is a special cause. And then what are the benefits after implementing the solution? The benefits are, there are some monetary benefits and there are some intangible benefits. So monetary annual savings are 43 lakhs 74,000 per annual per year after implementing the solution. And intangible are it reduce the cycle time and customers will be satisfied, and improve the morale of staff, etc. These are the intangible benefits. And these are the technical learnings and team learnings. So they got to know more statistical tools like cause and effect diagrams, scatter diagrams, control charts, Pareto charts, and brainstorming techniques. And it improved their skills. So this was the second project. Now I quickly run through the third project as well. So because we are running out of time, so we have 15 more minutes. So let me quickly show you the third project as well, which is from a service organization. The idea, the objective of this project is to reduce the delays in constructing the surveillance towers. So the project name is reduction of delays for surveillance towers construction. So define phase, the same process, IPOC. We have understood the process in a high level way, and these are the customers, and output is the surveillance tower, and the process is designing, construction, procuring the items, and then roll out or do the delivery, then do the inspection, and then hand over to the customer. Inputs are so many inputs are there, and these are the suppliers. And then these are the this is a project charter. We have collected the from the last 2 years, the whatever the data which we have with us. As per the data, there was a delay in constructing the towers, which is 3 months. For each tower, we are taking more than 3 months. So the objective of this project is to reduce the 3 months to 0 by October 2020. So, and what are the benefits? The monetary benefits are approximately 864,000 approximately. It increases the revenue. If you reduce the time, it increases the revenue. And these are the timelines. Then Gantt chart we have. Then measure phase, we collect the data on the output, and then also X factors. So we are choosing the data time to construct the towers, how many samples data, which is 21 towers we had constructed, and then this was the data collection, continuous data types, and the source, etc. And these are also the causes. And once we collect the data, and we did the histogram to understand the average time taken to construct the towers. So on an average, we are taking 25 months. This is in months. So 25 months to collect the data. And then these are run chart just to look at the trends and patterns in the data. And then we measured the sigma level of the process. So we have 21 towers total. Constructed towers are 21, out of which 14 towers had taken more time, which is more than target is to complete in 24 months. But these 14 projects towers have taken more than 24 months. So the DPMO is 666,677, and sigma level of the process was 1.07. This was about measure phase. Then we did the cause and effect diagrams and identified the possible causes why there were more delays in delivering the towers to the customer. So these were the possible causes. And we also used a tool called control impact metrics to prioritize those causes, because there were so many causes, which is some causes are out of our control, and some projects are which are in our control. So we have used this control impact matrix to see what causes are in our control, and if it is controlled, then what is the impact of our problem? Is it, are they going to be impacting highly or medium or low? So we use this, and then we had collected the data, and we did a Pareto chart to see which cause is most frequently occurring. So we came to know that communication issues, inconsistencies in implementing SOPs, and then quality of the material. These are the most frequently occurring causes. And then we further, we also started understanding the detailed process flow chart of the construction of these towers. These are detailed process flow chart. And then we also collected the data on communication issues, and then the other causes which are identified in Pareto. And then we started doing the scatter diagrams and hypothesis testing. So these are hypothesis testing we did to understand whether the tower construction time is impacted by the communication time. So if you take more time in communicating to the people who are working in the process, is it going to affect the project tower construction time? So since both of the data, which is a tower construction time and the communication delays, which is also time, we used a correlation, and correlation value is here 0.578 and p value is 0.006. So since p value is less than 0.05, uh, we have accepted the alternate hypothesis because the tower construction time is impacted by the communication. If you take more time in communicating the requirements to the people, it's going to affect the tower construction time. And then the other X factor, which is inconsistencies in SOP implementation, the time taken to follow the SOPs, and the time construction in month. So the null and alternate, null says this X, whatever the X that we are having here, is not affecting or not impacting the Y, and alternate is it is impacting the Y. So p value is 0.001, which is we accept the alternate, which means the tower construction time is impacted by the inconsistencies in SOPs implementation. And then the quality of the material, we perform the 2 sample t-test, and then standard material quality yes, and not material quality no. And then the p value is 0.004, which means that we have to accept the alternate. So tower construction time is dependent on dependent of standard quality of the material. If you have a good quality material, yes, the construction time will be less. That's what it is. These are the conclusions. These are all the 3 causes which are affecting the Y output. And then we started generating the solutions, and we had implemented the solutions. Here also we used a technique called 635 technique. And then we did the brainstorming. And these are the solutions which we implemented. And this is a implementation plan. This is a solution and implementation plan. After implementing the solution, we further collect the data. We had collected the data, which is I think 15 samples, 15 projects data we had collected, and this is a run chart. Then we perform the capability comparison before versus after. Then this is the improvement. So earlier we were having 66% defects, and after implementing the solution, the percentage has reduced from 66 to 21. Okay. And is it significant? Yes, it is a significant. So we did, this is a capability after implementing the solutions. So earlier I think it was 1.07 sigma. Now after implementing the solutions, our sigma level has improved from 1.07 to 2.30. And is the improvement significant? We did a 2T test before and after, and the p-value was 0.001, which means the improvement is significant. Then after looking at the improvement, we move to the control phase, and we measured the controls. We plotted the control charts to understand whether the process is in control or out of control. So yes, it seems that process is in control and performing well. So earlier earlier we were taking 25 months to construct the tower. Now the after implementing the solution, it has reduced from 25 to 22 months. And once after we saw the improvement, we made a control plan so that the construction time would not take more time. So we made a control plan, which activity needs to be verified and who is a responsible person and the frequency and what action needs to be taken if the responsible person says that the activity is going out of control. And then after implementing the solution, these were the benefits before Sigma and after Sigma. And the monetary benefits are savings, which is approximately 489,600 SAR reals. So these are cost benefit analysis after implementing the solutions. So this was about these 3 improvement projects from manufacturing and service organization.
Wow, Gopi, that was really fantastic. And thanks for sharing these projects. And any one thing you would like to tell our the budding black belts and green belts? Anything you would like to tell? Would you like to say something to them? Any message or any guidance? I think you can unshare your screen.
Yes.
And the good point was that you were able to share so many projects in such a short time. Okay, idea was that people get an idea how to
Idea.
complete the projects, and that's really you did a I would like to congratulate you for doing a great job. And any special advice you would like to give to our budding green belts and black belts, because they are always looking for doing a project, or sometimes they are looking for uh, uh, some basic guidance from people experienced people like you who have already completed the project. So anything you would like to tell them?
Yeah, so Lean Six Sigma, it's a beautiful tool to improve the process. So whatever uh, there are so many methods or so many tools in Six Sigma which can help you to improve the process. So it is not necessary that you will have to implement all the tools whatever you learned during the training program. It is not required. So choose any tool that you are comfortable with and implement the tool. It can be a Pareto chart, it can be a scatter diagram, it can be a box plot or a hypothesis testing. So choose a small, when you are starting the project, choose a process which is in your control. So do not choose do not try to boil the ocean. So choose a small improvement project. So once you implement, once you see the progress in the process, then you take, starting taking the projects which is interconnected or with the other cross-functional projects.
That's really good. That's I think one mistake people commit is that they try to do too many things in the first project. So that's a very good thing to, as Gobi mentioned. And I think we are almost coming to an end of our quality talks. So I would like to thank you, Gopi, and Anil. Thank you for organizing this quality talks, and Naveen and Anil are the backbones behind this quality talks, and we'd like to wish you, both of you, also happy New Year's, and all the people who are watching and who will be watching. It may happen that right now people are readying, getting
Ready for
ready
the
the New
party.
Year's celebrations. But if Anil, you can come on screen. So just would like to thank you a lot, and Naveen also, if you want to come on screen, we would like to thank you as well for the last during the whole 2020, the way you have managed, both of you have managed the whole quality talks. It was just fantastic, and wishing everyone a very happy new year, and just get ready for your celebrations, and we'll not stop you. And uh, so once again, this is Amitabh Saxena signing off from Quality Talks, along with Gopi Krishna, who shared his projects, and also Anil Kumar and Naveen. Anil Kumar, I think he's not able to come on screen. So thanks a lot.
Thank you
And
so much. Thanks everyone. Thanks you Anil and Naveen for organizing this session. And I wish you a happy new year to the one who is viewing and the one who is going to view the session.